Hi, I'm Carlisle Hashem, and this is the Carlisle Hashem Show. And today we have with us Earl Meredith, who is with the National Oceanic and Atmospheric Administration. And Earl is the coordinator for the Chesapeake Bay Sentinel Survey.
Sentinel Site.
Sentinel Site. There was an S there. Earl, thank you for being with us today.
Thank you for having me.
Could you tell us a little bit about yourself, your work, and what the Sentinel program is all about?
Sure. Well, I am on a developmental assignment in the Chesapeake Bay office for NOAA in Annapolis, and I've worked there for 2 months now. But my regular job is with the Northeast Fisheries Science Center in Woods Hole. And so I'm here working as a coordinator for the Chesapeake Bay Sentinel Site program, which is a cooperative among other federal agencies and other line offices within NOAA. So I work for the National Marine Fisheries Service, but we also integrate with the National Ocean Service and the National Geodetic Service. And we also work with universities such as University of Maryland at Horn Point and the University of Old Dominion, and the University of Virginia Marine Science Institute, or VIMS, down in Gloucester Point, Virginia. We also work with other federal agencies such as the National Park Service, the National Geologic Service, and then state agencies.
There are going to be a lot of acronyms and terms that we might not be familiar with, although here on the Eastern Shore, there are a lot of biologists who and just people who study nature will know what you're talking about. But tell us about what CBIBs are.
Okay. I'll try to define all the acronyms if I use one. So CBIBS is the Chesapeake Bay Interpretive Buoy System, and it's part of the International Ocean Observation System, IOS. And it's a series of buoys up and down the bay to record meteorological and oceanographic and water quality kind of data. And it's available through a website so the general public can access it. And people like teachers and schools can gather that information and use it in their educational process, but also it's used for modeling purposes, for modeling the effects of climate change and ocean change in the bay. And it's also used by the general public. For sailors, for example, can access the wind and tides and currents information on the CBIBs.
And how often is that monitored? I mean, could I go on it one day and then it would change the next day?
It changes essentially by it's various different sensors on the buoy itself are recording data in real time. Sometimes down to a minute or less.
Wow.
So it's very real-time data, and you can access it. You can download large chunks of that information for modeling or for educational purposes.
Now, this study here in Chesapeake Bay is one of 5 sites that you're working on around the country?
Yes, the NOAA Sentinel Site program is a nationwide initiative of networked organizations, and there's 5 sites that were selected in 2012. So there's a site in Hawaii, in San Francisco Bay. There's a site in the northern Gulf of Mexico. There's a site in North Carolina, and then of course the Chesapeake Bay Sentinel Site program that I'm the coordinator for.
And what makes the Chesapeake Bay site so unusual in its what you have to study about it?
Well, the objective of the Sentinel Site is to monitor and model sea level rise and sea level change. But in the Chesapeake Bay, which is the largest estuary in the United States, we're also looking at aspects of subsidence, where the ground is actually sinking a little bit. due to geologic phenomena that dates back to the Ice Age, the last Ice Age. And the effects that the ice shields had on this area now are still being manifest by the geologic processes of the land actually sinking. So the combination of sea level rise and subsidence is a little bit of a double whammy for this area. But also because of the oceanographic characteristics of offshore Atlantic and the Gulf Stream, for example, the water level is rising because of the expansion, the actual expansion of the ocean, which is expanding partially due to just the water temperature itself. So the old physical or physics equation with pressure and volume and temperature, the ocean is actually expanding because of the water temperature rising.
Let's go back to that geological phenomenon that a student at Saints Peter and Paul impressed upon me, that this meteor came down and hit the bottom of the Chesapeake Bay and created this crater there, and that geology, it continues. It's just not that when that happened 31 or 30 million years ago or whatever it is, that the effects from that continue to happen to this area.
That's right. Yeah, that meteor hit about 35 million years ago, and it created a crater about the size of Rhode Island. And that affected the drainage patterns in the Susquehanna River and the Chesapeake Bay, which eventually drained and filled that void up. And so that even today, that 35 million year ago event has effect on how the drainage systems were established.
When we were talking about the ocean expanding because of the global warming, so I envision then if I put hot water in a cup, is it the sides of the cup that would possibly expand?
Well, yeah, I mean the just the heat of the water translating that to the cup, there would be a little bit of expansion, but because the cup is more solid, it wouldn't expand as much as the liquid would. So essentially, if you look at the bay as a coffee cup, the shore is there, the water is rising a very small amount, but it is rising. And then it's inundating the shoreline areas and salt marshes, and it's having an environmental impact on those areas. And it's also going to have a socioeconomic impact on the communities, the human-built infrastructure around the bay. So that's primarily what the Chesapeake Bay Sentinel Site Program or Sentinel Site Cooperative are pooling together a number of data resources from our partners, such as municipalities and the other organizations, the other universities. They're collecting data, and we're bringing all that data together to create modeling tools to help inform communities and to help monitor what environmental impacts sea level rise is having on the Chesapeake Bay habitat areas.
And this is fascinating because this is cutting edge in the sense that this is the highest level you've gotten to yet, and I'm sure there'll be higher levels still in the ways that you're studying the water around us. Yeah.
We use a number of different measurement tools, and some of it's based on the standard elevation tables that are created in marsh habitat. So there's steel rods that are driven down into the ground until they can't be driven down. They're essentially hitting bedrock. And then we survey that back to the national geologic elevations standards that are small discs that are placed all around the country, and they're all linked back to one elevation in Canada. So it's a standard elevation around the entire country, so everybody's measuring off of the same level. And so those set tables in the marshlands are linked back to that. And then there's a sophisticated measuring tool that can attach to the top of that rod. And then it helps us monitor very accurately the change in elevation of that salt marsh area.
And that's being done on Poplar Island. NOAA's work on Poplar Island have those rods.
That's correct. Yeah, we have set tables throughout the entire Chesapeake Bay watershed.
And you were saying that that way of measuring the water is being done around the world.
Correct. Yeah, set table it's an international sort of standard, and they're creating a large database of all of the set tables around the world, so that we'll be able to, compare our water level changes on the same plane as water level changes in South Africa or Australia.
Well, we are going to be back in a moment. Stay with us, and we'll be talking more about sea level rise and the work that NOAA is doing to measure that.